In this example, we are told a force of magnitude 90 newtons is applied to an object of mass 15 kilograms for 5 seconds. The initial velocity of the mass is 10 meters per second, and we're asked to calculate acceleration. So again, we know that R equals M times A. What I've done is drawn the body as a particle, and the force that is being operated on it is 90 newtons. I've indicated the force by drawing in the arrow. Like we did before, we can say vector R equals mass times acceleration. Now, the only force operating on this in the horizontal direction is the force of 90 newtons. Now that 90 newtons is operating in the I direction, so I've written it as 90I equals mass. Well, we know the mass is 15 times acceleration. Now, acceleration is a vector quantity. We can write that as A times unit vector I, because the unit vector I is giving the direction. A is just a magnitude. So we now have A times unit vector I. We no longer need to worry about the unit vector I because this is all operating in the same direction. So we now have 90 equals 15A. Dividing both sides by 15, A is equal to 6 meters per second squared. So we now know our acceleration. Next part of the question says calculate the velocity of the object after 5 seconds. Again, V is equal to U plus AT. I can use that because I have constant acceleration. The constant acceleration is 6 meters per second squared. We know how long the time period is going to be for. We're told 5 seconds, and we're told the initial velocity was 10. So we have 10 plus 6 times 5, which is 40 meters per second. Last part of the question, we're looking at distance. So we know the initial velocity u is equal to 10. We're doing this for 5 seconds, so we know time is 5. We know the acceleration is constant and is 6. So I can substitute into the formula ut plus a half at squared. Solving that, I get 125 meters.